Early software required deliberate inputs, a specific click, a keystroke, a targeted tap. Today, that mechanical relationship is increasingly defined by a single, continuous motion. This shift was accelerated by a specific change in user experience design, the systematic removal of the Next Page button. While the infinite scroll is often presented as a convenience, it functions as an active mechanism for maintaining user presence within an interface. By prioritizing unbroken engagement, modern interface design creates a system where the physical act of scrolling begins to take precedence over intentional navigation. To understand how an interface influences behavior, we have to look at its primary biological target, the human reward system. Specifically, software interacts with the ventral striatum. This subcortical processing center is responsible for evaluating the value of new stimuli as they arrive. The infinite scroll provides this region with a variable reward schedule, delivering content in a stream that the brain must constantly reevaluate. By dissecting these mechanics, we see how the interface is designed to transition the user from active navigation toward a more reflexive pattern of swiping. This connection suggests that our digital environments are calibrated to interface with subcortical systems, creating a direct link between software code and biological response. The ventral striatum evolved to help us identify and pursue new resources, assigning value to unpredictable signals in our environment. It is most reactive to a variable reward schedule, a scenario where a reward is delivered at unpredictable intervals. If a reward is predictable, the brain maintains a baseline signal. But when rewards arrive at variable intervals, the brain produces massive, disproportionate spikes in dopamine. These peaks are contrasted by the low-value waiting periods that precede them, creating a cycle of anticipation and delivery. This inherent vulnerability to unpredictable patterns is the foundation for operant conditioning, the process of learning through rewards. We can analyze how physical environments are constructed to exploit these variable rewards, most famously in operant conditioning chambers. B.F. Skinner demonstrated that behaviors become more persistent and harder to extinguish when the reward for an action is randomized. This principle is the engine of the slot machine. The user provides a physical input, the pull of a lever, to trigger an unpredictable outcome. Digital interfaces apply this same logic. The continuous upward swipe, or the pull-to-refresh gesture, functions as the modern digital equivalent of that lever. A platform's algorithm manages the payout, interspersing highly engaging wins among a stream of more mundane, low-value posts. By applying these behavioral constraints, the interface feed adopts the functional characteristics of a casino machine, encouraging a state of manufactured compulsion. While the delivery of the reward is vital, the system's effectiveness also depends on the concept of friction. Legacy interfaces were built around pagination. When a user reached the bottom of a list, the experience hit a natural, physical boundary. Encountering a Next Page button forces a mandatory pause in the experience. This friction point requires the brain to engage the prefrontal cortex, the region responsible for executive function and conscious decision-making. That brief activation window allows for the execution of impulse control, giving the user a moment to decide whether to continue or to disengage. In this context, friction acts as an architectural defense mechanism that supports goal-directed navigation. To eliminate this pause, software engineering utilizes data prefetching and auto-buffering. The algorithm loads the next block of content in the background, ensuring that the user never encounters a visual endpoint. This removes the visual and physical cues that trigger a cognitive pause. Without that pause, the system bypasses the prefrontal cortex. Control of the behavior then defaults to the subcortical ventral striatum, which is already primed by the variable reward schedule. By removing friction, the interface downgrades the user's experience from a conscious cognitive decision to a reflexive loop. Here is the integrated system. Server data flows to the UI, prompting a swipe, triggering the ventral striatum. Without friction, these stages fire in an unbroken circle of continuous engagement. The executive function path remains disconnected, completely bypassed by the speed of this frictionless loop. This integration is a precision-engineered symbiosis between software delivery and biological vulnerability. The behavioral power of the infinite scroll comes from this synchronization. the perfect alignment of variable rewards and zero friction. While these interfaces are presented as tools for seamless navigation, their structural design tells a different story. The evidence suggests that the reduction of user impulse control is a direct result of these specific design choices. The architectural intent of these platforms is to maximize the duration of use by fostering a state of continuous interaction. This design paradigm leverages our biological architecture, systematically aligning software delivery with our inherent reward responses. As long as UI architecture prioritizes frictionless rewards over cognitive pauses, human impulse control will face a persistent challenge from engineered reflexive design.